Hello grade 7s, Natural Sciences. I'm Helen. Let's look at what we're learning about today. Remember that our topic at the moment is acids and bases and neutral substances. In today's lesson, we're going to learn something called the pH scale. So stick with me, and by the end of our lesson today, you're going to know all about the pH scale. Let's do a little bit of revision. Remember that we know that there are certain chemicals called indicators, acid-base indicators, that just like the lights at the back of a car can indicate or show us which way the car is going to turn or whether the car is stopped or reversing, those indicator lights show us what the car is about to do. Well, chemicals called indicators can be used to test for acids and bases. And the acids and bases are going to change the color of the indicator, not the acid and base isn't going to change color. They're going to cause a chemical reaction with the indicator, and they'll cause the indicator to turn color. And remember, in our last lesson, we learned about litmus, and we said that blue litmus paper, here we go, here's a sample of blue litmus paper, it's going to turn red if it's dipped into an acid, but in a base, it stays blue. On the other hand, red litmus paper is going to turn blue in a basic substance, but it'll stay red in an acid. And of course, litmus is not going to change color at all in a neutral substance. So if we put red and blue litmus paper into water, pure water, we're not going to get any change with either piece of paper, and that tells us that the water, the pure water, is a neutral substance. Now, can litmus paper tell us if something is a very strong acid or a very weak acid? Can it tell us the strength of the base? So we know that certain substances like toothpaste and soap are safe to taste and to touch. But other basic substances such as bleach and hypochlorite are very unsafe to taste and touch. Could litmus paper tell us how strong the base is or how strong the acid is? The answer is no. The litmus can only tell us, yes, this is a base, yes, this is an acid. That's all it can tell us. So the first thing we have to determine is, what is the measure of the strength of an acid or a base? Remember, we said that acids have lots of hydrogen or ions, positively charged ions. So strong acids are going to have lots of hydrogen ions, and weak acids are going to have fewer hydrogen ions. Same for bases. Strong bases are going to have lots of hydroxide ions, and weak bases, like toothpaste, for example, they're going to have less hydroxide ions. But how can we measure the strength of an acid or the strength of a base? This is a problem. A scale, I'm sure you're familiar with scales, are used to measure mass. We put an object into the top of the scale, and the little arrow will tell us how much mass that object has. So the scale can tell us, and we can compare things that have a large mass with things that have a small mass. Now, in the same way, have you heard of something called the pH scale? And it's written very strangely, isn't it? It has a small or lowercase p and a capital H. Have you heard of the pH scale? Well, in the same way as this scale can measure mass, the pH scale is a measure of how acidic, basic, or neutral a substance is. So strong acids have very low pHs. The scale runs from 0 to 14. So an acid that has a pH of 1 is going to be a much stronger acid than an acid that has a pH of 4. Around 7, we see that pH 7 means it's a neutral substance. Right up at higher numbers, pH 14, for example, those are very strong bases going up towards the higher numbers, and weaker bases are going to be closer to neutral. So this pH scale helps us to work out the strength, or to be able to look at an acid and say, this is a very strong acid, so it's going to have a low pH. Or this is a very strong base, it's going to have a high pH. This is a basic substance, but it's not very basic. We can touch it or taste it, so it has a lower pH, but still on the basic side of the pH scale. Now, in high school, you're going to learn a lot more about the pH scale, and it's a very interesting way of determining the chemical nature of a particular substance, dependent on whether the substance is acidic or basic. Can litmus paper compare the acidity of substances? Or can it tell us the degree of alkalinity of a solution? So let's say that we have a solution, and one solution is bleach, and the other solution is soapy water that we use to wash our hands. We know that it's safe to touch soap. We know that if soap got into our mouth by accident, it's not going to harm us. But we know that bleach is unsafe on our hands. It's going to corrode our hands. It's going to burn our hands. And it's definitely not safe to taste. If we put red litmus paper into soap and bleach, remember, red litmus paper is going to turn blue in a base, but it's just going to turn blue. That's all. It's not going to show us light blue and dark blue, for example. Litmus paper can only tell us if a substance is an acid or a base. It can't tell us how acidic or how alkaline the substance is. It just says yes, base or acid. That's all. In order to determine the strength of an acid or the strength of a base and to place them somewhere on the pH scale, we need another indicator. Litmus is pretty good, but it's not the best. So we have another indicator that is called universal indicator. So we're starting to see that universal means it can be used to test acids and bases and everything in between. So universal indicator isn't one substance, like litmus is just one particular substance. Universal indicator is a mixture of different chemicals that are placed onto that special neutral filter paper we learned about before. And each of these different chemicals that make up the extract on the universal indicator paper is going to change color differently according to the strength of the acid or the base that it is testing. So this is what universal indicator paper looks like. It is usually a yellow paper, whereas we know litmus is red or blue. So soon as we look at a testing paper that is yellow or even white, we know that we're looking at universal indicator paper. We've also can get universal indicator as a little bottle, a solution that we can use a little dropper, and we could drop a little drop of universal indicator into a substance in order to decide whether it's alkaline, how alkaline, or whether it is acidic and how acidic. So this is how indicator that is called universal indicator works. If we put the indicator paper in something that is very acidic, it will turn red. Slightly less acidic, it's going to move from red to orange to yellow. Neutral is going to show us, neutral, remember, pH 7, is going to show us kind of a green color. 8 and 9, they're all greens. And then as we move towards the very basic side of our pH scale, 10, 11, 12, 13, and 14, we're going to go from blue into very deep blue or purple. So that's how we very often illustrate our pH scale. We use the colors that universal indicator would change to. Remember, it's not the acid or the base that changes color, it's the indicator chemical that changes color. So this whole range of colors that the indicator paper would change to, we illustrate on our pH scale using this particular range of color. So we didn't just choose those colors to make it look like the rainbow or to make it look pretty. Those colors mean something in terms of universal indicator. So here's our sample. What kind of liquid do you think this sample was put into? Well, we can see that it's reddish, and we would say it's probably around about pH 1. It's not quite turning yellow, so we can't say it's pH 2 yet. So in fact, this piece of indicator paper was used used to test a very strong acid. All right. Now, let's have a look at the pH scale and some of these normal household products that we've been exploring over our last few lessons and determining what their properties are and whether they're acids or bases. And let's put them on the pH scale. We start with pure water, not rainwater, pure water, which we say is neutral. pH 7. Milk has got lactic acid in it, but not a lot. It's very, very close to neutral. In the same way, blood is slightly alkaline, not very alkaline, just a little. When we start moving towards the stronger acids, we see that coffee is in fact quite a strong acid. Tomatoes are quite strong. Vinegar has a pH of about 3. Lemons right down at 2. Our stomach acid can go as low as 1. And battery acid, sulfuric acid, is down at pH 0. Baking soda, which I told you is a safe alkaline for you to touch, is up at pH 9. So it's a weak base. Tablets that you might take called antacid tablets, they are medium bases. Ammonia solution and our soaps are becoming more acid. Bleach is a much stronger acid, and drain killer has a pH of 14, meaning it is a very strong base. So we've used a pH scale and we've used universal indicator today to show us how acidic or how basic a particular solution is. And that's it for today. Goodbye.